SwayamPrabha. Digital India. Educated India.
Hello, welcome to this course. This is the course on elements of solar energy conversion. So, I am Dr. Jishnu Bhattacharya from Mechanical Engineering Department, IIT Kanpur, and this course actually is a very targeted course for the solar energy technologies, whoever is going to use it or whoever is going to learn it, how it is used. That is a course for this reason. And there are few courses on this even online, but this particular course will target those people who are basically have some background already in terms of heat transfer analysis or the basic physics of sun earth relations and all those things. So, we will assume that this particular background is already there, and we are going to focus from the next step. But not only that, we are also going to look at some basics as well, because often these things are so common that we forget and to pay attention to that. Particularly they are taught in schools, and after that when we actually want to use these technologies or this information, then we fumble because we did not pay that much attention when it was introduced to us. Okay, and in this particular point, I would like to share some my personal thoughts with you. When I teach in a classroom, it is more interactive. Students can pause me and question me. Here also, of course, you can pause me by clicking a button. However, questions, they have to wait. Okay, so that is a fundamental problem in this type of teaching, this mode of teaching, but it has some advantage as well. What is the advantage? The advantage is you can take it at your own pace. If I am going too fast, you can pause me, you can think what I said, and then you can go ahead with the rest of the lecture. So, that is the plus point. Another thought I want to share you before I start anything is that this is the age of information abundance, right? So, you have enough information around, and you do not have to sit through a class or watch this particular video to learn or basically to gather the information. So, when you are taking this course, please keep this in mind that the information collection is not the motto or goal of this course. Okay? For any class or anything you want to learn and you want to gather knowledge, knowledge is rather intuition than the information. Okay, information you can search anywhere in the web and you will find so many information that I cannot even deliver in this course. Okay, so keep that in mind. What do I mean by intuition? Intuition is like when you go through the course and maybe a year or two after you have finished the course, then also you will carry some feeling or some intuition at some inner level, which you can use whenever you look at a problem. an engineering problem related to this particular course, or some decision you want to make. I mean, you are making a, I mean, you are installing some air conditioner, where to put the external unit for a split air conditioner. So, all these things are related. So, you use your learning on solar energy, so that you can utilize it in your life. Okay. So, let us start. This is the first lecture. So, this is lecture 1, and I should write the course name as well once. Elements of solar energy conversion. Okay. So, we are going to cover all kinds of conversion technologies. So, our main focus would be the thermal part, thermal conversion. Okay. Of course, we will cover the photovoltaic conversion, because otherwise the course will be incomplete, right. But our major focus would be here, particularly because there are plenty of information already available, or plenty of courses as well are available on photovoltaic conversion. Okay. So, what we will do, we will focus more on thermal conversion, and the photovoltaic part we will add for the sake of completeness. Okay. And the target audience, I should write what I expect. The target audience is either advanced UG students, maybe preferably 4th year mechanical engineering students, or even electrical engineering students. Okay. So, that is the and another one is the PG students, that means either master degree or PhD students who would like to pursue their research in the field of solar energy conversion. Okay. So, this will be an introductory course for them, and for advanced UG students, the background that they have in first 2-3 years of their engineering courses, those will be used heavily in this course. Okay. So, those are the target audience, and expectation from the students that I have is they will have some background in thermodynamics, fluid mechanics, okay, heat transfer, and basic physics. This kind of background I am looking for. So, before you start, you ensure that you have that background, then only you will be able to follow and enjoy the course. Okay. That is the fundamental principle. If you do not enjoy, then you will not be able to build that intuition that I am talking about. Okay. Now, let us give a outline for the course which will be followed. Okay. So, we will divulge the whole outline as we go, but for the first couple of lectures let me put what we want to cover. Okay. So, first one would be just to introduce the very basic concepts that are related to solar radiation. Okay. Then next thing we will talk about the sun, okay, because that is the most interesting body in the whole thing. Okay. So, we have to understand what it stands for. Now, we will talk about the spectral distribution, okay, of the sunshine, and then the very important earth sun relationship. Okay. Because that will tell how much we are going to get on the earth and how we can enumerate them correctly. Okay. Then we will, I mean, for this whole thing what we will require is the revolution and rotation of earth, okay, because that will come as a factor in this sun earth relationship, which is not a static thing, it is a dynamic thing and we have to capture the dynamics. Okay. Now, we will talk about the seasons and the position of the sun in the sky. If you look up, what position you will see in the sky, and we will also need to put the same thing, position of the sun with respect to the center of the earth. Because otherwise the position of the observer or wherever you are going to put your conversion technology, there that is going to change, right. You can do it in India, you can do it in some other country, within India you can use different cities or rural areas. So, we have to have some fixed point with which you can generalize the principles of this sun earth relationship, and that reference point will be the center of the earth. Okay. So, that is what we are going to talk about in the first couple of lectures. Okay. Now, first thing is what we said is the solar radiation. That is the first thing we would like to understand. Okay. So, you can see the sun is the source of all forms of energy that we see on the face of earth, right. So, understanding solar radiation is very fundamental in understanding life in general, and for this particular course it is very fundamental because that is the source that we are going to harness and use it for our purpose. We have to convert it to some usable form of energy, either heat or electricity, okay, so that we can transport it and we can use it. Now, So, whenever we talk about radiation, if you have some background, very basic background in heat transfer, you know that anything, whatever you look at, whatever you can see, maybe where you are sitting, you have a fan on top of your head, you have a pen in your hand. So, all these things, whatever you are seeing, everything is actually radiating some energy. So, that is the first principle we have to understand. Everything is radiating some energy. Okay. Now, here is a catch. You must have heard about the absolute zero, temperature absolute zero, right. So, here what I said, everything, I should specify that everything above absolute zero. Then only the statement will be fully correct. So, everything above absolute zero is radiating some form of energy. Okay. And what is the form of that energy? That is, we call electromagnetic, or we should call electromagnetic wave. Okay. So, all these energy that is getting radiated, those are in the form of electromagnetic wave. So, why do we call it electromagnetic? Because these waves are affected by electrical or magnetic field. Okay. So, either electrical or magnetic field can alter these waves. That is why we call it electromagnetic wave. Okay. And the very interesting feature of these electromagnetic waves is that it does not need any medium to be carried. Okay. It does not need any medium, right. And that is why the solar radiation that is getting radiated from the sun is actually being able to reach our earth, okay, because there is nothing in between, right. If you say that in more stringent terms, there is ether, but that is also a construction, that is a theoretical construction, right. So, physically there is nothing there, and even then the radiation is being carried to the earth. So, that is why we need electromagnetic wave to actually reach. It does not need any medium. And how this solar radiation is happening? Actually, we can call these waves. So, we know of these wave particle duality, right, that is also I am assuming you heard of. So, what we can say about this electromagnetic wave which is coming through the coming in the form of solar radiation, that is our. So, we can talk about the photons, which are basically packets of energy, as if they act like particles. So, these photons which are packets of energy, those photons as if it is getting distributed or getting emanated from the sun and going equally in all directions. So, photons are getting emitted from the sun and going in all the directions. Okay. And of course, those photons they do not know where Earth is, where Mars is or whatever. So, what they do? They do not have any bias, they are going equally in all directions. So, you can think of sun to be a sphere, okay, and these photons are going equally in all directions. Okay. So, basically what is happening, this is somewhat looks like a kids cartoon, right, when they first draw sun, and that is actually happening. Those are the, you can think of, you cannot see them, but you can think of the photons are going to be emanated just like this. Okay. And they are going and they are equally distributed in all direction. Okay. Now, how much of that total energy that is getting emanated will actually reach Earth, we will see in a minute. Okay. Now, if we look at this energy, it is not these all these photons, they are packets of energy, but they have a distribution, they are not all of equal energy, or they are not all of equal characteristic. So, the characteristic of a wave is the wavelength, right. So, we can find out or we can talk about the spectral distribution of this electromagnetic radiation. Okay. So, now I am taking a back step and I am talking about electromagnetic radiations in general term, not what is coming out of solar radiation. We will talk about it in a while, but let us talk the whole spectrum of it in the most general term. So, what we can see that we can write the wavelength in micrometer and we can write what kind of electromagnetic radiation it is. Okay. So, the most shortest wavelength electromagnetic radiations are called cosmic rays, okay, which are coming from different cosmic bodies in space. Okay. Now, if we go to little higher range, then we will get X rays and gamma rays. These are also known to you from your basic physics knowledge. Okay. Now, what we get in the next stage is the ultraviolet rays, and ultraviolet rays are also subdivided into few. So, first we get the far ultraviolet, then we get middle ultraviolet, and what is the range for that? This is the range for middle ultraviolet, and what we call near. These all names we have invented, the humanity has invented it, because our reference frame is our eye, right. Whatever we can see as if that is the reference frame we fix, and whatever is close to it we call near, and then little far, middle and all those things. Okay. But in nature does not know which one is the reference frame, it does not have. Okay. So, in absolute scale these naming convention does not mean much, but we can. Now, this is the most prominent electromagnetic radiation that we experience. Everybody with eyesight they can see the visible light, okay. But other than visible light, all kinds of radiations are actually coming and going around you from different electronic gadgets, from sun, even from stars, and nebula and everything, and the visible light, that is what we see. Okay. So, that range is 0.38 to 0.72 micrometer, and beyond that what we have 0.72 to 1.5, we call it near infrared. Infrared is often also called IR, okay, and these ultraviolets, these are called UV, ultraviolet, okay. And beyond which we have middle infrared, okay, and far infrared, and when the wavelength is very long we called it microwave or radio wave, okay. Those also we experience every day, but we do not see them. So, you can see here that this is our, so this is our reference frame, because we see that, we experience that so vividly, and I mean when the wavelength is smaller we cannot access them visually, but we get them, okay. So, what we can see that the UV part, that is the next to our reference frame, and the when the wavelength goes above we call it IR or infrared, okay. Now, with this knowledge of spectrum, if we look at solar radiation, where are we, okay. So, sorry. So, now if we look at solar radiation and look at the wavelength range of it, that is 0.15 micrometer to 3 micrometer, okay. So, if we go back and see 0.15 and 3, where are we? So, here, so we are in this range, right. So, we are in this range where solar radiation is obtained, okay. So, a narrow range, okay, and centered around the visible light, okay. Now, so what we are within far UV to middle IR, okay. This is the solar radiation range that we are getting, and out of that, so if you look at this range, then the visible range is 0.38 micrometer to 0.72 micrometer, Okay. So, if you compare these two range, so if you compare these two, what we get is that the visible is a small portion of what is available from the sun. Okay. So, it seems that okay, it is very bright today, that means lot of solar radiation is coming, that is true, but there is more to that what we cannot see, both in infrared range as well as in UV ultraviolet range. We cannot see the radiation which is beyond the visible light. Okay. So, that is the whole point. Okay. Now, all this radiation, let us go to the source now. Okay. Now, source is sun. Okay. So, we have understood somewhat about the range of solar radiation. Now, we will talk about the source of all this radiation. Okay. So, what is sun? It is a big ball of fire, right, that you know, and it is about 110 times in dia compared to earth. Okay. So, yeah, it is a big ball of fire. Okay. So, it is much bigger. So, in terms of volume it will be cube of this, okay, 110 times only in the dia. So, what is the dia? The dia is 1.39 into 10 to the power 9 meter, that is the dia of sun, and it is these many meters away, 1.5 into 10 to the power 11 meter away from the earth. So, you can think of it as 100 suns away. Okay. So, I mean, I always stress on the intuition development. When you are learning, you should focus on the intuition development, because all these numbers 1.39 into 10 to the power 9 you are not going to remember after 2 years. Okay. And you do not need to, you can look whatever you can look up, you do not need to remember that. Okay. But the intuition that you develop, that is irreplaceable. You cannot look up your intuition. Whenever you think of a problem, if you just want to know how big sun is, you have to know that it is 110 times in dia. That number is easier to remember, right? And how far it is? It is, you can place 100 of suns in between sun and the earth. Okay. So, that is how your intuition develops. So, whenever you think that I am going too fast, you please pause the video and then you develop, you think of yourself and you develop these intuitions. Okay. And everybody has his own method to develop it. So, I do not want to tell you that, you have to find it out. Okay. So, now coming back to our source, the sun, it is like this, and one small bit of information that you do not know maybe, or some of you may know, that sun also rotates. Around its own axis, just like earth rotates, that is why we get day and night, but sun also rotates, okay, its own axis. Now, and it is much slower, that is all, much slower. How much slower? It takes. So, now there is an interesting twist as well. While the earth rotates, all the portions rotate simultaneously, right, because it is a solid body, but sun is a plasma, or you at best you can think of as some gas or fluid, right. So, when it rotates, not all of it rotates simultaneously, it is the equatorial portion of the sun rotates faster and the polar portion of the sun they rotate slower. Okay. Does it make sense? Yeah. So, much slower of course, and the equator portion or equatorial portion takes about 24.5 days. Day here means our earth day, okay, 24.5 days it takes to rotate, okay, and the polar portion it take 38 days. Okay. So, that is about sun, and this solar rotation we are not bothered much because it does not affect the radiation that we receive. Okay. So, it does not affect the radiation, and that is why we do not care about the solar rotation. Okay. Just a fact I wanted to share with you. Now, what matters is how that radiation is getting generated, okay, because that will tell us the spectrum of it and all other details. So, the structure of sun that matters. Okay. So, if we look at the structure of the sun, and let us not draw the whole circle, but we can draw it in a semicircle. Okay. So, the core of the sun is extremely high temperature, extremely high pressure, right, that you can just imagine, and temperature here is about 8 to 40 into 10 to the power 6 Kelvin, very very high temperature, okay, and pressure here is 10 to the power 9 atmospheric, okay, again extremely high pressure, and density is also reasonably dense compared to any other portion of the sun. Okay. So, that is the core of the sun, and that core is defined to be about 0.23. So, this core we can talk 0.23 of r. R here is the radius of sun. Okay. So, 23% of the radius of sun is actually considered as core, and beyond that all the interesting stuff that are happening we call it radioactive shell. Okay. We call it radioactive shell. Okay. and that is about 0.7 R. So, up to 70%, from 23% to 70% we call radioactive shell. Then we have a convective shell, okay. And then we have photosphere, then we have chromosphere. I am not going to go into details, okay, but it is good to have some idea of the source of the radiation that we are going to work with, okay. And then at the outer boundary which we actually see from the earth, that is called corona, okay. And do not get scared by this name. When I am recording this video, it is still, the whole world is under lockdown and other very severe restrictions. People are scared of a virus named coronavirus, and I hope when you look at this video, the world got rid of this coronavirus, but the actual name comes from the sun, okay. So, actually the virus, if you look under the microscope, it looks like something is radiating from a center, and that is why it is called a coronavirus. But the name comes from the sun, which is the outer layer of sun, is called corona, okay. But all the structure of the sun is very interesting. However, what it boils down to is how we are going to represent the sun as a source of energy. So, how to represent the sun as an energy emitter. Okay. We cannot consider all these core, chromosphere, corona, all these things, we just simply cannot. We have to have very simplified model of sun, and that simplified model is a black body assumption. Okay. Again, I am assuming that you have some basic understanding of radiative heat transfer, you are familiar with what a black body is. So, black body is nothing but a idealistic assumption of any energy emitter which does not have. So, a black body, it absorbs everything or every radiation, and it emits every radiation. That is what it calls, I mean that is what it means, what a black body is. So, basically if you talk in terms of radiative heat transfer, the emissivity or absorptivity, both of them is equal to 1, okay. And the reflectivity or transmissivity, all of them are 0. That is what a black body means. So, this complicated structure of sun, what we can do, we can assume it to be a black body. So, sun can be assumed a black body maintained at at 5762 Kelvin. Okay. So, So, at this temperature, if you just replace the sun, you place a black body there at this particular temperature 5762 Kelvin, then you will get the similar kind of radiation that we receive as solar radiation on earth. Okay. So, that is what it means, but again any assumption is, but this assumption like any is an oversimplification. Okay. Why I call it oversimplification? Because the radiation spectrum that we obtain on earth does not exactly match with the black body. I am just abbreviating that with BB, black body radiation at 5762 Kelvin. Okay. That does not exactly match, but it is a reasonably close assumption. So, in science what we do, we give start with a model and then slowly introduce complexities on that model. If we start to model the whole thing at a time, then we will never be able to do it. That is why we start with the closest model and then slowly introduce the complexities in it. Okay. And actually it is not about this temperature, 5762 Kelvin is not the culprit. It is that the solar radiation cannot be captured as a black body radiation. Why all these things? You have to go in much detail about solar physics, solar chemistry, how it is transferred and all those things, which is beyond the scope of this course. So, let us stick to what we observe rather than explaining it. Okay. So, ultimately what we get is I mean this is not, the figure is not to the scale, just I want to give you some idea where this lies. So, what we are plotting here? Here we are plotting wavelength in micrometer in the x axis, and in the y axis we are plotting solar spectrum rather spectral irradiance. Okay. And that is in watt per meter square micrometer. Okay. So, basically what we get, let me draw some numbers as well. Here it is 0.4, 0.8, 1.2, 1.6 and so on. Okay. So, the okay, sorry, I need to demarcate the 500, 1000, 1500 and then 2000 and maybe 2500. Okay, here. So, let me draw the solar spectrum with the red one. and it goes up to, and you have lot of wiggles here, and it comes down where the wavelength goes up for the infrared region. Okay. Now, if we compare this solar spectrum with black body radiation at that 5762, it closely matches, you can say, or it goes off. So, again at the infrared range it closely matches, and in the other range it does not match exactly, but it closely matches, particularly the peak value. Okay. Peak matches closely for, this is the black body radiation at 5762 Kelvin, okay, and this is the solar radiation. Okay. And this is called, this particular radiation we call it WRC spectrum. WRC stands for World Radio Communication Conference. So, it is a global body which designate that this is the standard solar spectrum, because we will see the solar spectrum is also not a universal like invariant thing. It changes with many parameters, where you measure, when you measure, and all those things. So, we have to fix that, okay, this is the standard value. So, we will take it from this particular monitoring body, World Radio Communication Conference. Okay. So, now so this is the difference, and also we will see that this particular solar radiation is not that what we get on the crust of the earth. This is what we get beyond the atmosphere. When from the sun towards to the atmosphere, at the end of the atmosphere, the radiation quality does not change. Okay. And when we talk about the earth crust, where we actually see the solar radiation and we can actually harvest energy and all, there is a significant difference, and that is what we are going to see in the next class. So, this is the basic, the first class introduces you with the basics of the structure of the sun, basic of the solar radiation, how we can conveniently model it with some black body assumption, and where it differs. Okay. In the next class, what we are going to see is the extraterrestrial radiation with respect to the on the crust or terrestrial radiation. Okay. With that, I would like to thank you for your attention and see you in the next class.